Hi everyone, welcome back to our video series for Stata for HED611. This is video 8, and in this video I'm going to show you how you can create variables in Stata that standardize another variable. So first we need to get on the same page about what it means to standardize a variable. Think about two continuous variables, say grade point average or GPA and family income. Now, since they are both continuous, you can calculate a mean and a standard deviation for both of these. However, if you are just trying to compare those things, it gets tricky. Clearly, GPA and family income will have wildly different means and standard deviations, because GPA only has a range from typically 0 to 4, and family income has a range from 0 to in the millions. But if we converted both of those variables to z-scores, then we know that both new variables would have a mean of 0 and a standard deviation of 1, and we can compare across variables better. Here's the great news. The most basic way to do this involves commands you already know. You just need to know the math and logic to make it happen. So let's go back to the auto dataset. And let's say that we wanted to look at miles per gallon and weight. Well, just like GPA and family income, those two variables have very different measurements, so means and standard deviations are not going to be as helpful. Well, what do we know about z-scores? We know that a z-score is the observation minus the mean divided by the standard deviation. So if we wanted to create a new variable, that is the z-score for miles per gallon, we know that we will need the mean and standard deviation for miles per gallon. To get that, we'll type summarize MPG. And we get the mean to be 21.2973 and the standard deviation to be 5.785503. That means that for any observation in the dataset, the z-score is the observed value minus 21.973 divided by 5.785503. So we can simply type generate mpg underscore z to indicate that it's a z-score variable equals, open parentheses, mpg minus 21.2973, close those parentheses, divided by 5.785503. Before I hit enter, let's review that logic. What we are telling Stata to do is to create a new variable, and for each case, set the value of that variable to the value of MPG minus 21.2973, and then that subtraction divided by 5.785503. Also, this is a good time to remember to pay attention to the order of operations. Stata uses the correct order of operations: parentheses, exponents, multiplication, division, addition, subtraction. You can remember this with the mnemonic, "Please excuse my dear Aunt Sally." Since without the parentheses, Stata would want to do the division before the subtraction, you need to put in the parentheses. So let's hit enter. If we open the data browser, we can see that the new variable has been created, and we can see that the values are all roughly between plus or minus 3, which the empirical rule would predict. You'll also see the standard deviation is 1. The mean is not quite 0 due to rounding, but it's very close to 0. Let's do the same thing with weight. First, we'll summarize. Then, we'll generate a new variable using the mean and the standard deviation. So now we can see why we might do this. Let's summarize MPG and weight, the original variables, first. See how the means and standard deviations are so different? We have no way to compare them. But if we summarize the two new variables, we see they now both have means that are practically 0 and standard deviations of 1. We can also look in the data browser and see that we have two new variables where we can really compare apples to apples. So that was the shortcut way. If you are satisfied with that, you can stop watching. If you want to learn a little bit of advanced programming, keep watching, but you will not be tested on this. The problem with the shortcut method is that these commands, while practical when making the commands directly for a single use, are useless in terms of writing do files for use in a long-term research project. Consider this. If we wrote these commands into a do file, they would become useless if our dataset changed in any way, because the commands are based on the means and standard deviations of that exact dataset. But what if you get more observations? That code is no longer valid. The solution is to use what are called return lists. When you use the summarize command, Stata temporarily stores some of the results in macros, temporary storage units. You can see what Stata is storing after a command by using the command return list. So let's summarize MPG, and then let's type return list. You can see exactly what is being stored by Stata in those temporary macros. So let's open a do file, because that is where you would most likely use this. This is how we would generate those standardized variables without using the exact values that might become useless. First, we add to our code to summarize MPG. You need to have the summarize command first because those macros are temporary and don't even exist until you run the summarize command. Then, we can do our generate command. Generate MPG, we'll call this underscore Z2, equals, we're going to start the same way. MPG minus, now instead of putting a specific value, we're going to put R mean, because that's how it's stored as a macro, is R mean. I'm going to close the second set of parentheses and divide that by R SD, which is how Stata stores the standard deviation after a summarize command. What this does is that when you run this code from the do file, it will use the newly calculated and stored mean and standard deviation, making the generate command accurate regardless of how the dataset may have changed. So let's do that. If we summarized MPG Z, the first one that we did, and MPG Z2, the second one we did, you can see that the mean for the second one is even closer to 0 because there is an even smaller rounding error. We can also look at the data browser to see that the new way got us the same results. But we can be confident that if we have to run the same code again, we do not need to think about changing the data. That's it for this video. Let me know if you have any questions about those return lists.